Good morning all. Today I'm looking at the Jackery Explorer 500 portable power station. So this is a big box of lithium-ion batteries, 518 watt hours, and it's also got a 500 watt pure sine wave inverter. Let's do an unboxing. Inside is the bag of accessory cables, also manual with warranty card and a 12-month warranty extension. And here is the Explorer 500. Let's switch on the liquid crystal display. That's showing 78%. I have been charging this with solar. I'll put those shots in later. This input here is for both the solar panel or the power supply, which is a 24 volt power supply. There's a DC section here. This is a 12 volt 10 amp cigar lighter or accessory socket. Now these two 12 volt sockets are not 5.5 2.1s. These are actually 6.3s, I believe, but they work with standard laptop adapters. Now I found that both these laptop adapters, one which I think is 6mm with a 1.4mm pin, the other one I believe is 6.3mm, not quite sure what the diameter of that is, but these both fit. These incidentally, if you're looking through your set of laptop adapters, are the Type A and the Type B. Both these fit in here, and these are rated at 7 amps, and I guess that's why they didn't use the 5.5 2.1, but these adapters convert it to that in any case. Here there's a set of 3 USBs. Now these are vanilla flavor, 2.4 amp 5 volt USBs, no fast charge here. And here we have a UK shuttered 230 volt output from the 500 watt pure sine wave inverter. On the sides we have a fan outlet, and on the other side a fan inlet, and there's also this light which you can switch on, and if you press and hold you get an SOS function. Let's look inside the bag of bits. There are 2 items in here. One of them is the 12 volt charging cable from your car cigarette lighter socket to a 7.9mm plug, and the other one, which also has the 7.9mm plug, is the AC power adapter. It's 24 volts, 3.75 amps, 90 watts. So let's plug in that AC adapter. The power station powers up and it's charging at 86 watts. So to check pass-through mode, I've got a 100 watt incandescent bulb here. Let's switch on the AC inverter. On comes the bulb and we can see that we've got 84 watts coming in from the AC power adapter and 97 watts going out to the incandescent lamp. So yes, this Explorer 500 has pass-through mode. Now I just wanted to do a size comparison between the Jackery Explorer 240 and the Explorer 500. That probably shows it better. The 240 is very light, easily portable. The 500 is perfectly carryable. It's not heavy, but it's got some weight to it. It's the perfect size to carry around a useful ½ kilowatt hour of stored energy. So let's get the Jackery on the bench and do some tests. Now the first thing I want to try is to compare the power supply that was supplied with the 500, and that's the 24 volt one, and that yields 86 watts into the unit. And then I want to compare that with the other power supply. Now this is the one supplied with the Explorer 240, and this one is 19 volts. That gives 68 watts. So it seems that in a similar way to the Explorer 240, this Explorer 500 has a largely voltage dependent input circuit. So the more volts you give it, the more watts you'll get going into the battery. Now, as luck would have it, or lack of luck I suppose you'd say, the camera ran out of supply, so I'm plugging that into the USB, so that will be on as well. But let's put the, I'll just check my ammeter, or my electronic load dials are down. Let's put the DC on and see how many watts we can pull from these 6mm sockets. Okay, turn this up to 7 amps, 5 amps, 6. Okay, that's 7.3 amps on the electronic DC load. We're pulling 96 watts. Let's take it higher and see when it drops out. 8.3 amps, 108 watts. 9.6 amps, 127 watts. 10 amps, and I can hear a howling and whistling sound. And that's the maximum I can pull. Something's shut off, and I do believe it's the DC section. Right, now testing the cigar lighter or accessory socket. Let's turn that on. I'll put the fine up, which gives me 2 amps as a starting point. Let's start turning the coarse up. Okay, that's 8, that's 10 amps. This thing is rated at 10 amps, but I imagine, oh no, it has actually cut out. Okay, interesting, let's try that again. Okay, I've got that at 130 watts, 10.1 amps. It's making that squealing noise again. 10.3 amps, 132 watts, 10.4 amps, 134 watts, 10.8 amps. Oh, the display has gone off. Yes, and the DC output has gone off. So this one does cut out not much above 10 amps, so the protection circuit is working fine. Right, onto USB sockets. Now I've got this one with a USB DC load set to 2.4 amps, and it's fine. I'm going to increase that. So that's 2.5 amps, 2.6 amps, 2.7 amps, and the fan has increased in speed. Right, the little monitor unit has switched off and this fan appears to be slowing down. So I think what's happened is the socket has cut the power, but the USB light is still on. Now I assume that's so that it can keep the other sockets going. And in fact, if I look at my camera, I think that's charging. Yes, that is still charging. So the socket that hasn't got an overload condition is still working. Now if I remove the overload condition, yes, this thing's come straight back on again at 2.4 amps. So these are protected, it looks like, on an individual basis, so that each one is protected at about 2.6, possibly 2.7 amps. It cuts off, but it doesn't shut down the USB subsystem, so other devices on the USB carry on working. That's actually rather good. So moving on to the AC outlet, let's switch that on and check the AC voltage, and that's coming up at 228.8, so approximately 230 volts. And so we have a fairly good looking sine wave there, 229 volts, and it's 0.05 kilohertz, which is 50 hertz. So the next test I'm going to do is a full discharge into an oil-filled radiator, which is about 460 watts, I think. And this is a 500 watt inverter. I'm just going to charge this fully to 100% using the supplied AC adapter. So we'll do that first and then discharge it and measure the total discharge in watt hours. Right, this thing's been on 99% now for quite a while, possibly 45 minutes, but I've noticed that the input power is now falling 75 watts and it's falling steadily. So this is in its constant voltage phase, but it does look like it's also calibrating the state of charge indicator, possibly. One would only know that if you did this several times and look to see how long it's on 99%, but this is definitely now falling. I think the unit is getting close to being fully charged. And for the full discharge test, I'll need to pull out the charging supply. I've got an oil-filled radiator on the end of this piece of wire. That I think runs at 460 watts or thereabout. So let's turn on the AC, plug in this energy meter which can measure the full discharge, and turn on the radiator. The fans have come on this unit. 435 watts. I've tilted the unit up so that the displays are easier to see, and so far we've clocked up 51 watt hours and it's displaying 91%, which is about right, I think. 50 watt hours, 10% of the battery used. I'll come back probably around 50%. So we're at about 50%, 51%, and we should be at 259 kilowatt hours, which is half of the 518, and we're doing a little better than that, 264 watt hours, 51%. And here again at 10% it flashes the display backlight 10 times according to the manual. So at 10%, 465 watt hours. And now down to 1% battery remaining. It's done 505 watt hours. So I don't think it's going to run for much longer. Hasn't done the 518 watt hours indicated in the manual, but then that is a nominal capacity of the cells. It doesn't take into account the inefficiency of the AC inverter, and it's switched off and we've got 508 watt hours. So as I was saying, in here it says 518.4 watt hours, 24 amp hour battery at 21.6 volts. So that is a 6 cell pack, and we're not far short of that actually. So sunny day test with the Solar Saga 100 watt panel connected to the Explorer 500, and we're getting 76 watts. 74 watts. Now that was a little higher when the panel was cool. I was getting 76 watts. As it's warmed up, it's dropped a couple of watts. And again, similar to the Explorer 300, if you use a bigger solar panel, this is 160 watts, then it doesn't actually make any difference. We're getting the same at 72 watts now that the panel has warmed up, and that's because it's not about the current. This panel can deliver more current, it's about the voltage. It's the same number of cells, and so it's the same voltage, and we're getting the same charge power. So that's the Jackery Explorer 500. This is a neat system. It's very quick to set up, particularly when you use the Solar Saga 100 solar panel. You can install that just in a few seconds. Charging does take a while. It's 7 hours from the supplied mains adapter, 8 hours from a vehicle, and the manual says up to 14 hours from the Solar Saga 100 solar panel. So this is available on Amazon UK from today with 15% off. That's during Jackery Explorer week. That's the 17th to the 19th. And you can get an additional 5% off for the whole of May using my special code. That's Julian 2021. That's it for now. Cheerio.